Science 1, Standard 9, topic Work and Energy. Today we will discuss in details about positive work done, negative work done, and zero work done. So let us discuss the direction of force and of displacement in each of the following cases. Look at the examples given here carefully. Pushing a stalled vehicle, catching the ball which your friend has thrown towards you, tying a stone to one end of a string and swinging it round and round by the other end of the string, stopping a moving car by applying brakes. Now you will notice that in some of the above examples, the direction of force and displacement are not same. They are different. So now we will discuss in details how they are different, what are they called as. So in the first example, the direction of applied force and that of displacement, they both are in the same direction. So it is called as positive work done. In the second example, the ball has thrown towards you. So the direction of the force and that of displacement, they both are same. So this is also an example of positive work done. In the third example, the stone is moving in circular direction. So the displacement and the applied force, they both are perpendicular to each other. So when the force and displacement are perpendicular to each other, it is called as zero work done. In the last example, the force applied and the displacement, they both are in opposite direction. The force is applied on the steering wheel and the car will move in the forward direction, and when the brakes applied, so the car will stop and move a little bit in the backward direction. So both are in the opposite direction. Now, as we have seen, the direction of the force and displacement decide the type of work done. So, the work done is divided into three types: positive, negative, and zero work. So, when the force and displacement are in the same direction, that is theta equal to 0 degree. Why it is 0 degree? Because there is no angle between the force and displacement. They both are in the same direction. So, the work done by the force is positive. When the force and the displacement are in opposite direction, that is theta equal to 180 degree. So, the work done by the force is negative. And when the applied force does not cause any displacement, and when the force and displacement are perpendicular to each other, that is theta equal to 90 degree, the work done by the force is called as zero work done. Now you will see in the chart how this work done are said as positive, negative, and zero. In the chart given here, we will see why they are called as positive, negative, and zero work done. So when the value of theta is 0 degree, so cos 0 degree is 1. So W will become as Fs. So it is positive. So it is called as positive work done. When theta is 90 degree, cos 90 degree is 0. So W will become 0. So it is called as zero work done. When theta is 180 degree, cos 180 degree is minus 1. So W will become as minus Fs. So it is called as negative work done. So here in this chart we can see how it is positive, negative, and zero work done depending upon the direction of the force and displacement. By trying an experiment, we'll find more about positive, negative, and zero work done. In this figure A, we can see the cup is put on the table. The two end of the thread is tied by two nuts. One nut is in the cup and the other nut is hanging freely along the side of the table. Now we have to find out, why does the cup get pulled? Now the force applied on the thread is in the downward direction, and since the thread is connected to the cup, it will move the cup along its direction, that is downward. And now we can see that the applied force and the displacement, they both are in the same direction, that is downward. So hence we can conclude here that it is positive work done. As shown in figure B, we know that the cup will slide along the table. Now what we have to do, we have to stop it by putting a ruler in its path. Now we have to see what is the relationship between the displacement of the cup and the force applied through the ruler. Now we have seen in figure A, the cup will displace along the thread, that is in the downward direction, but here we are stopping it by a ruler. Now the force applied by the ruler and the displacement of the curve, they both are in the opposite direction. So what we can conclude here, when the force applied and the displacement are in opposite direction, so it is negative work done. As shown in figure C, keep the cup at the center of the table and leave the two nuts hanging on opposite sides of the table. Now what we have to find out here, why doesn't the cup get displaced? So for that we will see the figure. Now on both the sides of the table, thread is there, so the force will be applied by the nuts and the force will be same. And since the forces are same, the cup will not be able to move along the direction of the thread. And one more thing, the force and the displacement, they are perpendicular to each other. So we can conclude it here, when the force and the displacement are perpendicular to each other, or when the force does not cause any displacement, that type of work done is called as zero work done. Artificial satellite. Suppose an artificial satellite is moving around the Earth in a circular orbit. As the gravitational force acting on the satellite along this radius of the circle and its displacement along the tangent to the circle are perpendicular to each other. So what will be the work done by the gravitational force? The work done by the gravitational force is zero, because the force applied and displacement are perpendicular to each other. Let us know about National Physical Laboratory, New Delhi. National Physical Laboratory, New Delhi was conceptualized in 1943. It functions under the Council of Scientific and Industrial Research. It conducts basic research in various branches of physics and helps various industries and institutes engage in developmental work. Its main objective is to establish national standards of various physical quantities.